This hotel walkway was already too weak. Then, one design change doubled the load, holding it up. It hung 4 stories above a crowded dance floor inside Kansas City's Hyatt Regency. The revised rods forced both walkways through one critical upper connection. But investigators found that connection failed the design requirements before the change was ever made. This was not one fatal mistake. It was one unsafe design, made even worse. The Hyatt Regency's atrium was designed to feel open and weightless. 3 elevated walkways crossed the lobby. The second-floor walkway sat directly below the 4th-floor walkway. The 3rd-floor bridge was offset to one side. On the evening of the 17th of July, 1981, the lobby was crowded for a dance. At about 7 o'clock, the 4th-floor walkway dropped onto the 2nd-floor walkway. Both fell into the lobby. The later Missouri Court of Appeals opinion records 114 deaths and at least 186 injuries. Those numbers explain the scale. They do not explain the mechanism. For that, the National Bureau of Standards examined the debris, tested replica connections, reviewed drawings, measured materials, and calculated the loads believed to have been present. Its conclusion led to a connection small enough to fit on a drafting table. Each walkway deck rested on long steel stringers. Those stringers connected to crosswise box beams. The box beams were made from 2 steel channels welded toe to toe, creating a narrow, hollow shape. Vertical hanger rods descended from the roof. At each box beam, a washer and nut beneath the beam transferred the walkway's weight into the rod. That last sentence is the entire physical problem. The walkway pushed down, the rod, washer, and nut held up. All of that force entered the thin flanges of the paired steel channels at a concentrated point. In the contract drawings, one continuous set of rods descended from the roof, passed through the 4th-floor beams, and continued to the 2nd-floor beam. The 4th-floor walkway transferred its load into the rods at the 4th floor. The 2nd-floor walkway transferred its load into those same rods lower down. The upper box beam did not have to carry the lower walkway. It is tempting to call that original arrangement the safe version. The investigation did not. NBS concluded that even with continuous rods, the box beam hanger rod connection did not satisfy the applicable design requirements. The detail placed a concentrated load into a connection without the capacity expected under the building code. There is an important distinction here. NBS estimated that the original configuration would probably have carried the load present on the night of the collapse. But buildings are not designed merely to survive one estimated crowd on one evening. The code-specified design load included a safety margin for the range of loads a public walkway had to withstand. So, the original detail might have survived that night and still have been an unacceptable design. That is the first failure in this story. Before anyone divided one rod into 2, the connection was already too weak. During fabrication, the continuous rods created a practical problem. Installing the 4th floor nut would have required working it along a long threaded section of rod. The steel fabricator proposed an interrupted arrangement. One set of rods would run from the roof to the 4th floor walkway. A second set would hang the 2nd floor walkway from the 4th floor walkway. Visually, the revision looked modest. Mechanically, it changed where the lower walkway's weight went. Under the original arrangement, the 2nd floor load continued through the rods toward the roof. Under the constructed arrangement, that lower load stopped at the 4th floor box beam. The upper connection now had to transfer the weight of the 4th floor walkway and the walkway hanging beneath it. NBS said the change essentially doubled the load at the 4th floor box beam hanger rod connections. The appellate opinion recorded the same effect. The change did not create a weakness from nothing. It placed roughly twice the demand onto a connection that was already deficient. The critical hardware did not need to snap for the walkway to fall. As the washer and nut pushed against the underside of the box beam, the channel flanges around the rod hole deformed. The two channels could spread. The nut and washer assembly could pull through the damaged beam. NBS testing found that the connection's capacity could be predicted from replica tests. Debris deformation strongly indicated that failure began along the east line of hanger rods, most probably at the east end of the fourth floor walkway's middle box beam. Once an upper connection failed, the load moved violently into the remaining structure. The fourth floor walkway fell onto the second floor walkway below it, and the stacked system came down. This was not a story of cheap steel suddenly breaking. NBS found that the specified steel properties were met, and that material quality or workmanship did not play a significant role in initiating the collapse. The steel behaved according to the forces the design put into it. Crowds are the obvious suspect in a crowded building collapse. The load analysis points the other way. For the most heavily loaded fourth floor connection, NBS estimated the combined dead load and upper bound live load at about 53% of the code-specified design load. That does not mean the walkway carried 53% of its maximum possible strength. It means the estimated load acting on that critical connection was only about 53% of the load the code required the connection to be designed for. The people in the atrium did not ask the structure to perform an extraordinary stunt. The connection failed before reaching the ordinary design demand expected of a public walkway. And that brings the story beyond the nut, the washer, and the rods. The dangerous force path existed on drawings before it existed over the dance floor. The later disciplinary case examined responsibilities the NBS engineering report was not written to decide. According to the appellate opinion, the engineering firm's own procedures called for a detailed check of special connections. A technician reviewing the shop drawings raised questions about rod strength and the change from one rod to two. The project engineer treated the revision as basically the same concept. It was not. The commission found that the shop drawings were not reviewed for whether the box beam hanger rod connection met the Kansas City Building Code or conformed to the design concept. The drawings were approved. The court record also addressed the calculations behind that approval. The firm's files contained no record of a web shear calculation the project engineer said he had performed. The commission found that other necessary tests or calculations were not made. The appellate court called it reasonable to infer that the engineering work needed to determine the double rod arrangement's structural soundness was not performed. That wording matters. The record does not prove that nobody calculated anything. It supports a narrower and more consequential finding. The necessary work to establish this connection's safety was not done. The Hyatt project had already supplied a reason to look closely at the atrium. During construction in 1979, part of the atrium roof collapsed. That roof failure had a different cause. It was not an earlier version of the walkway mechanism, but it triggered something directly relevant. The owner and architect paid for a broader review of the atrium structure. The appellate record says the engineers were asked to inspect the bridge steel and connections. A later report said the suspended bridges had been checked and found satisfactory. The court record says a complete check of the bridge design was not performed. This is where the tragedy stops looking like a single missed calculation. The project had a deficient original connection. A fabrication change doubled its demand. Internal procedure required detailed checking of special connections. A technician raised the rod issue. An earlier atrium collapse prompted another paid review. Still, the built connection remained above a public lobby. Each layer was a chance to interrupt the chain. The National Bureau of Standards answered the physical question. It identified insufficient capacity in the box beam hanger rod connections as the most probable cause. The deformation indicated the likely initiating connection. Tests and analysis explained how the nut and washer could pull through. The original detail was inadequate. The constructed detail doubled the upper demand. The loads present were well below what the code required the connection to withstand. The licensing process answered a different question. What professional duties applied to the design and review? The Missouri Licensing Board revoked the registrations of the two engineers and the firm's certificate. The appellate court affirmed the discipline except for one misconduct finding connected to the broader atrium design review, which it reversed because that specific basis had not been charged in the complaint. That limited reversal belongs in the story. Accountability is not made stronger by overstating the record. Neither investigation needs a cartoon villain. Together they show a technical weakness passing through a human system that was supposed to catch it. The memorable version of the Hyatt collapse is true as far as it goes. The hanger rods were changed. The lower walkway began loading the fourth floor connection. The demand there essentially doubled, but that version begins too late. The original connection was already inadequate. The changed load path made it worse. The review process did not turn either configuration into a safe public structure. That is the complete mechanism. Not one bad rod, not one crowded dance, and not one isolated mistake. It was a deficient connection, an escalated load, and repeated safeguards that failed to stop the detail before construction. The smallest object in the story is the nut beneath the box beam. The largest is the assumption behind every review stamp that someone, somewhere, had made sure the load path was safe. At the Hyatt Regency, that assumption was carrying two walkways. As always, thanks for watching. If you enjoyed this video, feel free to subscribe. I'll see you in the next one.